Welcome to Science Access. In today's class, we are going to be talking about the chemical bond. And in particular, we are going to discuss the electrovalent or ionic bond. Now, in chemistry, we have the primary or the main bonds, which are the covalent bond. We have the electrovalent or ionic bond. The covalent bond is divided into the ordinary covalent and the dative covalent. While we also have the metallic bond, it's also a strong bond. And we have other weak bonds, which we are going to discuss as we go on in our classes. So let's talk about the electrovalent bond. But before we talk about that, why do elements actually need to bond? Now, you must know this. Just the way we are hungry and there's a desire for us to get fed, that is the same thing that happened to elements. Note this. The first shell, the K shell, actually require 2 electrons. So if the K shell has 1 electron, there is an innate desire in that atom for it to get the second electron. The next shell actually have or can carry 8 electrons, maximum of 8 electrons. Now, if there is 5, 6, or 7 electrons, there is this desire to attract electrons so that it can get filled. That is actually the desire. That is actually the reason for chemical bonding. In some cases, there is sharing of electrons. In some cases, there is transfer of electrons. One loses electron and the other one gains. So, in this electrovalent bond, it's a kind of bond that is formed when one element loses electron and the other actually gain electrons. So, let's discuss that using sodium chloride. We know that sodium chloride has an atomic number of 11. Sodium has an atomic number of 11, while chlorine has an atomic number of 17. So let's discuss electrovalent bond using this simple example. The first shell, we get as the K shell. First shell we get it as the K shell actually take a maximum of 2 electrons. The next shell take a maximum of 8. So you put 8 electrons in this 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8, that is 10 electrons already. So, and sodium has 11 electrons because the atomic number is actually 11. So that means that the number of protons is 11 and the number of protons is equal to the number of electrons, which means that the number of electrons is also 11. So in this case, we have 11 electrons. 10 has been placed into the first and second shell. The last shell will take the last electron. Now note that this last shell has just 1 electron, but it actually can take 8 electrons for it to be filled. Is it easier for this atom to actually get 7 or to give out the 1? It is actually easier for it to give out what? The 1. So note that. Why chlorine has atomic number of 17, which means the number of protons is 17 and the number of electrons is what? 17. So the first 2 will go into the first shell. Second will go into the 8 will go into the second shell. Now 2 plus 8 is 10, remaining 7. So the 7 will go into the next shell. But this next shell actually requires 8 electrons. So it needs 1. So in the reaction between these 2 compounds, there is a desire for one to lose this electron for it to become stable. It does not have 2 shells and it's not stable. And there is a desire for the other to actually gain 1 electron for it to become stable. So sodium plus chlorine here will now have something like this. This electron here will be transferred to this place. So we now have this third shell. There is no longer electron there. So we now have 2 shells. First shell and second shell. Now, here we now have a new electron here, right? That is what you have here. So this shell that actually have 7 electrons before, because it has gained 1 electron from this, it now has what? 8 electrons. So we cannot count 1, 2, 3, 4, 5, 6, 7, 8. Now, because this atom have gained 1 electron, it is actually now negative charge. And because this have actually lost electron, it's now positive charge. Let me tell you why. This has atomic number of 11, which means it has proton, 11 proton. Now, it also has 11 what? Electron. But if it loses one electron, it becomes 10 electron, right? So we now have 10 electron. There is one net positive charge in this place. While in this place, it has 17 proton and 17 electron. So if it gains one electron, how many electrons does it have now? 18. So you now have one net negative charge. So this atom, sodium chloride, is being held together by this force of attraction between the positive and negative charge. That is what actually holds this compound together. So this is a classic or a very simple example of electrovalent bond or ionic bond. Let's take a look at another example. So let's take a look at this second compound, calcium chloride. Now, calcium has atomic number of 20. It means that the number of proton is 20 and the number of electron is 20. So, as usual, we are going to arrange the electron in the shell. The first shell will take 2, the second will take 8, the third will take 8. So we have 2 plus 8 is 10, plus 8 again is 18. So it's remaining 2 electrons, and it will now be placed in the last shell. So the last shell actually have 2 electrons. So the next is chlorine. Chlorine has atomic number of 17. Chlorine has atomic number of 17. All right. Now, note that the first electron, as usual, will take 2, the second will take 8, and the third, 2 plus 8 is 10. So the third will now take the remaining 7. So this actually have 2 electrons in this atmosphere, and this have 7 electrons. It's easier for this to give out the 2 than to accept 6, and it's easier for this to take 1 electron than to give out 7 electrons. So what will happen? Now let's take a look at the net. Now note this, please. This is calcium plus Cl2. This is how the reaction actually takes place. We now have this calcium atom. We now give out these 2 electrons, but chlorine, one atom of chlorine will accept one, and another atom of chlorine will accept another one. So it means that one calcium atom will combine with 2 chlorine atoms. Take a look at it in this net reaction or the product. This is calcium chloride. We have calcium. I've already given out 2 electrons, so it's now 2 plus. Now this chlorine atom have taken 1 electron, and this have taken 1 electron. So we realize that the 2 atom that is given out in this place the 2 electron that was given out in this place, one was given to 1 atom of chlorine, another to another atom of chlorine. So we now have calcium 2 plus, but this chlorine has gained 1 electron, which is minus, and this one has also gained 1 electron, which is also another negative sign. So the net is actually this 2 plus, while we have chlorine, the 2 chlorine having what? Negative charge. So it's a very simple thing. Note that this whole compound, these 2 plus, the attraction between these 2 plus and these negative charges actually hold this whole compound together. So it's a very simple kind of bond and very easy to understand. So you can take this assignment and try out this magnesium chloride. Magnesium chloride is actually Cl2. Please note that, because magnesium belongs to group 2, so it has 2 electrons in this atmosphere, so it's combined with 2 chlorine. Draw the atom of magnesium chloride individually and draw how they carry out exchange of electron. Do the same for magnesium oxide and aluminum chloride. Realize that, note that aluminum actually have Cl3. So when you draw the diagram, you understand it. Your answer, you can always send your answers, snap or take a picture of your answer, then send it to biologyaccess@gmail.com. It's being displayed on the board. Thank you.